I'd like to introduce Stephan, Stephan Rocca, and his Director Business Development for PITSS GmbH, obviously a German company, and has been working for over 20 years in the Oracle software development and business intelligence ecosystem. And he does a lot of speaking at other conferences, but none as important as the ANDOUC, of course. So, and really just one more fun fact as we start is that Stephan is, unlike me, an athlete. He supported his, he financed his studies when he was studying to be a data scientist as a badminton coach. And he's still involved today. In fact, he sits on he helps out with the German Olympic Sports Confederation for badminton as well. So there's an interesting fact for you. So with that, Stephan, may I hand over to you? So thank you for joining us today.
Wonderful. Thank you, Roger, for introducing myself. Roger, could you see my slide deck? Just a quick feedback.
Yes, sir, I can. It's perfect.
Wonderful. Thank you very much. So yeah, you mentioned my study, and that is the first time in the mid-18th of the last century where I first get in contact with the graph algorithms, and I just love them. I just in the first lecture catch me, and I'm so happy to come back after such long period of time to be able to use the graph technology. In those time, I just go for driving home for Christmas, and I do a riddle for my parents and ask them what is the cheapest pass for Santa Claus running through a city, and just presenting the gifts. And from that time on, I totally the nerd in my family. So you know what I am. Okay, so I want to
love it. Love the humor. Very good.
So I want to give you a demo or a use case where we as a partner from Oracle use the Oracle Graph technology. And I want to start with the reason why our company is in the market, why we are existing. So we are totally focused on software development. So we help company to write and analyze and document better code. And we believe that software development getting complex day by day, and the longer software is on the market and existing, the more complex it is to maintain these software. And there should be helping our tools, our utilities, a product roundabout to catch or to reduce this complexity. And what we see is we focus on Oracle software development, and perhaps the one or the other know Oracle Forms. It's just a development framework which is on the market for around about 40 years by now. And with this, all these application ones written in Forms and still written in Forms have also more than 20-30 years of software development in their code. And so we see dramatically a need for analyze these software. So that is the reason why we start this speech to, or why I just want to allow this speech to get. That is how we analyze the code, and why is Oracle Graph very helpful for us. So first of all, these legacy code, these legacy applications are monolithic. Monolithic from different perspective. On one perspective, they do not decide between different layers. So the software itself merge together data and logic and user interface. Monolithic in reference to the cross functionality. So when you take care about security or configuration, customization, which cover by modern software frameworks today with extra libraries or extra configuration possibilities, that is all in one piece of code in the Oracle Forms environment. And its legacy code is monolithic in reference to the business perspective. So that means Forms applications are overwhelmed with features. So one release after the other, the developer decide, oh, I need another button, I need another item, I need another functionality. So the real business process and support, which is known by the user today while they consume modern applications, which are process flow driven. That is not the case. So we want to help customers to break down these monolithic. And what are the use cases for the Oracle graph? What are the parts in our tool where the graph technology could help us? There are 3 samples I want to show you today. The first one is, how could we identify bounded context in a legacy application? I will describe bounded context in 2 slides. And we have use cases for testing support. How could we support user testing of the application with graph? And how could we identify the business process? But let me start with the heart of our software. So the heart of our software is the application data cube. That is, all the implementation from the customer code is stored in our repository. So we load Oracle Forms, reports, PL/SQL packages, procedures, functions from in the database. We could load external SQL files, shell scripts, etc. Whatever is readable and parsable for us will be part of our application data cube. With this, we are able to identify dependency. By now, we provide our product on the Oracle Cloud environment, and that you will see that in a second in our demo. So we offer a software as a service solution running on the Oracle Cloud infrastructure from the 2 products, Java Cloud Service and Database Cloud Service. And the good news, and Melly mentioned that the graph database is available in any Oracle database edition, and that is motivate us to use these technology and adjust our way how we analyze code based on these functionalities. Right now, we provide our solution with the latest graph server version. We will see that in the demo part. As I said, we load software in our repository. That is, we also load PL/SQL code in our repository. And the main functionality of our code is we have very extensive parser capabilities. So we treat the code you write not as a text or CLOB or something like this. We treat them like the compiler did. So we build an abstract syntax tree out of this implementation. And so we are able to identify each statement, a procedure call, a loop, an if statement. We know what is the condition in the if statement, etc. And you may see that is tend to be a graph. So that could help us. This parser is not only available to parse SQL and PL/SQL, it also allows us to parse forms built-in functionalities. So when the user navigates through the application, showing another canvas or adding an item or changing the property of an item, all these forms built in, that is an extension to the PL/SQL language, is parsed by our parser. So we totally understood the logic of the application. That is good to know. That is a starting point where we could try to create and solve the first use case. The first use case is if you want to split down a monolithic application, you talk about bounded context. You want to split them down in web services or in smaller deployable artifacts so that your development team is able, that one team is running and developing and deploying the sales context and the other team is totally independent, developing the support context. And you see there are a couple of functionalities. And for a second, you could assume that these rectangles in that graph are perhaps part of your application, part in the sense of user interface, of business logic, of data model. So we have a pipeline part of your application. You manage salesperson and manage territory, etc., and that belongs to the sales context. So we do not have business know-how about the customer application. We load in between in the past 20 years around about 600 to 800 different application into our repository. And we are able to identify those dependencies without the knowledge of the real business. So what does it mean? That is a sample from a customer in South Africa running a forms application with 1,500 different forms modules. And we cluster them in different, we call bounded context. You see there's a bounded context taking care about the student, a bounded context taking care about the person. And if you want to drill down and want to dive into a little bit, you see that the student cluster is consumed by any other cluster 4 times, and itself consume other clusters with a very high number of 5,000. This is done in the past with domain knowledge. So we have to get in contact with the customer and ask them, could you give us a cluster, a group, a criteria? How could we identify which functionality belongs to the student cluster? And you see there's a huge amount of unassigned objects because the customer itself do not have a rule. How could I identify which cluster should be responsible for a specific functionality? So we left with unassigned object, and that makes life not as easy as it could be. And that is a point where Oracle Graph technology come in our life and in our product. And Melly mentioned it before, there are a huge amount of existent algorithms in the Oracle Graph database, over 60 she mentioned, which help us to do graph algorithms and patterns, etc. But more than this, beside the algorithms which are already presented and provided by Oracle, you have the possibility to write your own algorithms on top of those. And that is very helpful for us and very fancy. Because what we want to achieve is we want to advise bounded context without any domain knowledge. What are the reasons? What could help us to decide what are a subdomain, and how could we create these borders? Going back to the slide before, in this case, each of these rectangles represent a huge amount of forms modules. So single canvases, single screens of the application. In the person cluster, maybe 20, in the student cluster, perhaps 100, etc. All these canvases, these screens have function points like validations, buttons, business logic, SQL statement, etc. So we could count in our repository the function points which are available or accessible on a screen, and could with this we could create numbers as a weight for a screen. So a screen with 100 functions is more complex, has more functionality as a screen with 2 functions. So a cluster and a bounded context at the end should follow 2 rules. One of those rules is each cluster should have more or less the same weight underneath. It doesn't make sense to have a cluster with have 89% of all the functionality of my entire application, and the rest of 11% are distributed over 6 domains. That is not helpful. On the other side, the interactions between these clusters should be at minimum. So it should not very high interactions between one and the other clusters, because then my development team has the need to provide interface for other bounded context. And that is not the principle of bounded context. So we end up in a algorithm which follow usually a community detection, but which take in consideration the weight of the forms modules. And that is a sample I want to show. And for this, I switch to my environment for a second. You see my terminal window. As I said, we are running on a cloud environment. So let me connect to this cloud server. Oh, sorry. So we are connected to our environment. And in this environment, I first want to create the graph. So let me just run the scripts which are necessary to create a graph. And for this, we use the Python interface on that. So we just connect to the running graph environment. Okay. So that is our graph server we are connected to. And let's quickly create a graph based on the 2 views from our repository. So we do that over here, just copy and paste. You see, I do it in a very fast way. Let me just do this. Just 1 second. I want to create a new one. So I increase the number so that we really are able to create this. Wonderful. Okay, so then we just copy and paste the next statement. We just create this. We execute. Oh, I'll just make some errors. I believe the statement wasn't correct. This one should be the correct one. Oh, wait a second. That is what we see from the live demo. Okay, just stop this and do it once more. Just over here. Just going over here. Sorry, just make that larger for everybody to see. Once more, just connecting to this. Okay, and now we do the right one. Just this. We connect to the server. Okay, wonderful. Then now I just have this. As you say, we just do it in a simple way. We have two tables, forms and forms calls, which are the interaction between all these objects with the source and the destination and a very small label. So we create the statement. Then we are about to run these PGL statement. Okay, that's fine. Now I just pick up the graph over here, and it's no, not the forms 2. I just want to flow 3. Okay, let's do the right graph. So I have the green graph, and now I could just simply publish them. And now you see our graph presents on 265 nodes and around about 850 edges. That's a small application from one of our customers. And now we are able to consume these graph very quick over our user interface from the property graph wizard. So we connect, and you should see over here, it's the new forms flow arrived. And if I run these, there's nothing helpful right now, but you could see that are our forms modules with the forms name and the weight of the function points inside our repository. Now, for a second, we just able to bring that into better shape. I just present that in this way. If we take in consideration the weight of each module, we size the bubbles. The more complex the module is, the bigger the bubble is, but the nodes and edges, the connections are still the same. Now we try to consume our algorithm. So the algorithm is just based as a Java API available. So let's just see how this works. We just do this. We just created a Java algorithm and store that on the server. With this, we could compile these algorithm and just assign them to our graph and create a new attribute for the community ID and assign a weight that is a property weight we saw on these nodes. And then we are able to run this algorithm, and this creates a new community ID. And with this, we could consume or see these clusters. So I want to do that in a higher number of elements, and I just pick the one we already created. So with this, you see in the first second that we now have a community ID, which is created by the own written Java algorithm. And if I now change the highlights just to visualize the cluster, do that over here, and I do a rerun. We could identify that a cluster, I just pick out once only with the highlights. The yellow cluster over here is just the advice from the code that these objects belong very closely together and have in sum to all these other nodes the same value. And I could see how these are interacting with each other and what are the forms modules belonging to this cluster. So this helps us without domain knowledge, without the information, what are the responsible for the forms modules, to see how they are interacting each other and create these kind of community. So going back to the presentation, that is what we create over here. So as I said, I highlight only one of those clusters and remain the other ones. But with this, you could create as fine granular clusters as you like. So that is the first use case where we use Oracle graph technology to identify automatically these bounded contexts, and that's a brilliant starting point. By default, or more or less like an error, we figure out if we have all these information into our repository and we use a graph technology, we could help the user running a test. And that is what I want to present over here. You could imagine that it's very easy to create the shortest path algorithm on these graph technology to identify what is the shortest click path for a user from one login screen to a specific PL SQL unit. The use case is in a very, very large forms implementation, you do a release change. You implement a lot of functionality, and you are not using automatic testing because that is not so easy in Oracle Forms application. There's a tool, but no, not used very often. So you want to guide your users. What are the functionalities I've changed? And with our graph algorithm in the backend, we know the click paths, and we could visualize them with our mockup integration and help the user and say, okay, you have to press the green button in your toolbar, then the screen is pop up, and there you please press the archive, the claim button, and then the one I want to interest is a cancel button, because I have implemented perhaps a rollback functionality. So when we know that a function is changed, I know exactly what is the click path from the login screen to the end, to the unit I want to test. And that is done by more or less nothing. It's coming out of the box from the graph technology with shortest path algorithm. Last but not least, and from our perspective, the most interesting part is how could I identify business processes in the application? So how could I identify what are the really use cases from the application? That starts with data model analytics. So the data model analytic is necessary because applications which are on the market for 20 to 30 years are not well designed in the use case of foreign key relationships. Hand on my heart, most of the Oracle Forms applications are not well designed from the data model. Surely you could change them and assign foreign keys between the relation of the tables, but we know more than this because we know which tables are used in where clauses in the user interface, or which are joined for a DML statement in something like a package functionality. We know where the user interface create a master detail declaration between two tables. So nevertheless, even if there are no foreign keys on the table, we could identify the relationship between the data model between the tables. And with this, we are able to identify what are hot topic tables in your data model and which should be tracked for getting informed about the business process. So in our case, sorry for the German notation of the tables, it's an ERP system with more than 2,000 tables underneath. We see that something like article and delivery and some storage information are the most of interest table. With this information, we are able to enhance the application and bring cookies into the application to track the user behavior. And the reason why we use Oracle Graph technology is because we tend to visualize and analyze these graphs. So let me start the second demo over here. Sorry, we just go over here for the processes. I just log in myself for the session. And the cool stuff for this demo is, you may know that this user interface is an Apex interface. And we record the stories with all these user behavior underneath. So you see over here all steps which users do with the application, what he's doing, one step after the other. And we are able to integrate via a JavaScript interface or JavaScript API on the graph technology, the underlying graph technologies and visualize them. So we could create in an Apex application the same behavior, the same graph visualization. Because we are forced to use a known visualization, because what we want to do is we want to describe layers. On the top layer, you see the user interaction. So you see there's a tree node selected and a button pressed. So I run through this process. You see time constraint in between. So the user think about 2 seconds before you go to the other activity. And we have the possibility to interact Apex the other way around. So when I do a double click on such a node, I'm back into my Apex application and I see additional information about this node. And I could add some additional files, perhaps like nodes from a code review for this code. And by the way, I could also identify what is the code underneath. So what is the trigger good for? So, and on the other more deeper levels, I saw the business logic underneath. So what are the business logic related to the user interface and to the database? And I could see different colors remain in different screens. So he switched the screen from here to there because it's a different color. And the size of the bubble is the time consumed by these units. So I see the when list changed trigger is the most time consuming one. So that helps us to identify the business process, what are the user interactions, and how this runs through the application. So that is what we gain over here. And we could do that with the interaction from the JavaScript Cytoscape library or API based on the Oracle Graph technology. So what is the benefits from our integration of Oracle Graph into our product? So on one hand, we have the possibility to redesign a monolithic application without any domain knowledge, more or less from the domain-driven design perspective. We could directly dive into a discussion with the customer because we have a very good big picture of these domains. We could help to improve the user testing. So whenever there's a release change, we could guide them directly where something new is arrived and what is to test. And we could identify and visualize business processes. So where we are right now is just running the product integration into Apex. And that is very cool, very fancy. What we like to do is we want to identify subgraphs in the business process perspective. So the use case for this, and that is a reason why we are founded by the German government with a 2 years ongoing project, is to identify repeating business processes in the daily work. So whenever we identify what are the steps necessary, perhaps to create an order, could we identify these patterns in the day-by-day business of the entire company? And that is a part we are working on and we are very proud of. So that's more or less my story for today. I hope you could see that the graph technology is really helpful in our product environment and to use this for analyze legacy application. Thanks for this, and I just give back to Roger for, I believe, introducing
Thank you,
a rest.
Yeah, thanks, Stephan. that was superb. And yeah, old school still translates to modern technology, that's for sure. Yep. So yeah, well done. That was really interesting. Thank you, sir. Melly, I'll leave it to you to introduce Kim.
Right, and I think it was, yeah, to me fascinating that graphs could be used in this context. I mean, I would never have thought that. I would have thought, oh, graphs and legacy software modeling have nothing to do with each other, but clearly, I think Stephan and his team have done a really good job. So thank you very much for that.